Okay.
So you're now the host, and you can share if you like.
Okay.
Hello,
Alrighty.
hello, and welcome to this fine Tuesday morning. This is John O'Brien from the Keystone Contractors Association, and today we're gonna have a little electric safety led by PPL's own Doug Haupt. Uh, Doug, take it away.
All right. Thank you. Good morning, everybody. So we have gone to a virtual electrical safety presentation for this year, and we've been gratefully allowed to join the KCA organization and allowing us to just come out here and give a brief demonstration or talk about electrical safety for contractors. You are working near our facilities, depending on what you're doing every day as a contractor and possibly even as a homeowner. So we do our best to get out in front of as many organizations as we can to basically educate you on the dangers of electricity. Just one of the key points that that I'd like to start out with is on our safety. Safety, I'm sure, as it is for your company, just as it is for ours, is a number one. So, as a contractor, unless you're a qualified electrical worker, one thing to remember: you have nothing in your possession that would allow you to touch any type of wire, especially during storms. I know we had some last evening up in Wilkes-Barre area that were pretty severe, but storms come through and it may be during your work day, and you wait something out and trees and wires are down afterwards. Just because the lights go out, power's out, please, okay, don't think you can just walk over and start moving wires or cutting trees off wires. There's a lot of different things that can happen, and again, you just don't have what we have, allowing us to do the work we do. This is our lifeline, the rubber glove. Okay, rubber glove, nothing fancy about the leather glove, but the rubber glove here. For us, these are tested every 3 months. They're tested to 15,000 volts of electricity, and they're tested for a pinhole. A pinhole in this rubber glove right here would allow electricity to pass through into us, injuring us or possibly killing us. A pinhole, okay? But this rubber glove, if you see us out working, we have rubber sleeves that go over our arms, FR clothing, overshoes that we wear, a rubber overshoe. The gloves, the sleeves, and the overshoes, they're all tested, okay? They're tested to that high voltage because that's what we're working around and near every day. So this is our lifeline. This is the stuff that allows us to do the work that we do, okay? So unless you're a qualified electrical worker, some of you may be, and you may have something similar, but otherwise, you gotta just wait. And I know at times it can be hard, especially in storms. You gotta wait for us to get there to make it safe for you to continue on your work or do the work you're doing. Wire, all different types of wire. I'll show a slide to show you, but this is just one that I'd like to use for demonstration. This is a standard piece of service wire that comes into the side of your home. So from the pole out on the street, you got a piece of wire coming in overhead or possibly underground, feeding your home or business. The key point to this: so you have two energized legs, two hot legs, and one bare system neutral, sometimes three, depending on the size of the service coming in. But this coating here is what gets a lot of people, and a lot of people are confused on. I'll ask the question, and what is this coating? And the number one answer we get from most people is that this is insulation. Okay, it is not insulation. As a qualified electrical worker, we would give this 0 insulation value. It's a black coating to protect these two hot energized legs from this bare system neutral. And you can see here this piece, see how that's been compromised right there? Okay. So this wire may run through trees on your property. Our little critters out there, our friends, the squirrels, okay? You probably see them at times. They're running and dancing out across these lines. They love to chew this coating off. All it takes is a pinhole in that coating, okay? And if you were to grab a hold of this barehanded, pair of leather gloves, okay? If you look at leather gloves, sometimes they tell you they're electrically tested, okay? They're not electrically tested to allow you to touch this wire. This wire should not be here on you. If you're working on a ladder up cleaning the gutter, putting soffit fascia on, whatever it may be, this wire right here, I've seen it many times, okay, with customers and contractors. Should not be in that location, okay? Don't think you can touch this wire. OSHA tells you, and it's in my slides here that I'm gonna go to, but if you don't know the voltage of the line that you are working near, OSHA actually tells you you must maintain 20 feet to overhead facilities, okay? Whether that's with a crane, a backhoe, or you as a contractor in person, okay? If you don't know the voltage of the line and cannot verify the voltage of the line, you've got to maintain 20 feet. If you know the voltage of the line and what you're working around, then you can get within 10 feet, even to this wire, this service wire, okay? Which we get it at times. It's hard to do, especially if you're doing soffit fascia siding work, okay? You can put a request in. If you have to do tree removal, you got to do work near this line. For us, you can put a request in. You've got to do it well in advance, not something you could call today to have it done tomorrow. You got to do a little scheduling and planning with us, but we'll actually come out the day that is scheduled, and we'll either take the wire down, okay, as long as the customer is agreeable, obviously. We'll take the wire down for you, we'll de-energize the line for a set period of time, and then come back that day, put it back up or re-energize it, okay? We'll come out and make it safe for you. Just remember, it takes planning, weeks, okay? We have to have some time to get it in our schedule. But we'll come out and make it safe for you, okay, to make your job a little bit easier to work around facilities. All righty, so that's my safety portion. I'm gonna share my screen here and move over to a PowerPoint. So it says here, John, that Rich Wade has entered the waiting room. Okay, let me, since I'm the administrator, I'll hit admit. And we'll see if they're, okay. All right, good morning, Mr. Wade. Okay, all righty. So you can see my screen, John? Give me a nod there. You're seeing the?
Yes, I see it.
Okay, I think last time we had some issues trying to go to full screen, so I'm just gonna let it like this.
Okay.
And walk through this. I'll walk through this a little pretty quick here. So, maybe. Okay. Again, this is about safety for you as construction and even homeowners. Okay, understanding the dangers of electricity. Just a brief overview of how we get it from basically generation to the end user, our customer. So as PPL, we no longer own generation. We are strictly an electric delivery business. So we're buying our generation from a power plant. we transformers, that's what these things are doing. So got a transformer outside of a power plant that is taking approximately 23,000 volts of electricity, and we got to get it to a higher voltage in order to transport that voltage the long distances that we do. And we step it up to 230,000 and 500,000 volts of electricity to move large amounts of electricity across Pennsylvania. Then we take it to a transmission substation where we got to bring it down to a more manageable level where we have similar transformers to this. And these transformers then work the opposite direction, and we step it down from 230 and 500, and we step it down to 69 and 138,000 volts of electricity. And transport one more time today over what you see out there, us installing the big steel monopoles to what we call an area supply substation. And that substation, approximately 103 by 130 that you see in the residential areas. Inside of this substation, again, we have a transformer that basically takes the 69 and the 138, and we step it down to a distribution level of 12,000 volts of electricity. So 12,000 is the wooden poles that are outside of your home, 3 wires on top. That is for us 3-phase, and phase to phase is 12,500 volts of electricity. And we take it again through the residential areas, out on the wooden poles out in front of your home. You see the canister, the gray silver canisters that are up on a pole. Again, a transformer again. And these transformers are taking the 12,000 and or single phase, 1 wire up on top by itself is 7,200 volts of electricity in our system. So this transformer takes that 7,200, steps it down from 122 to 122.40 to bring it into your home, through this service wire that I talked about. So, and then the big green boxes, if you are excavators, the big green boxes are doing exactly what this transformer up on the pole is doing, except everything coming in and out of this box is under the ground. So that's how we get it from power plants, basically to our end customer, and get it to a level that it can be used. What's ours and what's communication and what's the responsibility of the homeowner? So everything on red on this slide is what we own. 3 wires here in this case on the pole, 3-phase, 12,500. We have a fuse out there. A lot of folks think we're blowing up transformers. If you ever see storms coming in and you see that blue flash off in the sky, and maybe even a loud bang outside of your house, okay? Much like in your home, if you do something with an electrical outlet that you're not supposed to do, what happens? It trips a breaker down in the panel box. So up on the pole, we have what's called a throttle and a fuse. And we protect the transformer with a fuse, just like in our homes. So that loud bang you hear is actually a fuse blowing, not the transformer itself blowing. And then the service wire over to the weatherhead, whether it be up on the mast or attached to the home. That is the demarcation. That's where we stop, and everything beyond that point becomes the homeowner's responsibility. Storm comes through, tree comes down on the service and it rips the mast or rips the weatherhead off the side of the home. The customer is responsible to get an electrician and to get all this repaired before we can, and inspected before we can re-energize the home back up at the weatherhead. And then just the meter itself. The meter is ours. The meter base is the responsibility of the homeowner. Out on the pole, top wires, transformer. The wire that is just below the transformer is our neutral or ground wire. So this is our operating space on the pole, from the ground wire up to the top of the pole. That's where our facilities will reside on a pole. Once you get below this system neutral, okay, everything below that becomes communication lines, your fiber, communication, phone, all that kind of stuff, and then bringing those into the homes as well. So that's what's out on the pole. That's what's ours, and the responsibility of a homeowner or a business. Our system, talked a little bit about it. Again, we got three-phase. You got the wire, you got the insulators, okay? All different variations of insulators, but the insulator is what physically stops the electricity from flowing into the pole. If we have to, this is what we call a dead end structure. We dead end into the pole, and then we take a lead from each of the phases through a fuse down into a transformer, and then the transformer is taking that high voltage and stepping it down 120 or 480 here because of a triple bank transformer. So taking it from the high voltage through the transformer into a business, more than likely in this case. The insulators, as I spoke of, we have porcelain, which are here on the top right. So we got the old porcelain, we got a porcelain ridge pin. We dead end, we go up over top through another insulator down on this side of this insulator. So it's how we get around the pole when need be. And then in this case, you'll see the different type of insulator. On the left of this pole is what we call the new polymer type insulator. So we have the porcelain and we have the polymer. Ridge pin on top, again, wire is fastened into the insulator and just goes straight through, but never contacting the pole itself. And then the big one down here on the bottom, this is actually an insulator string for a 500,000 volt transmission line. You'll see this is quad bundled. Each one of these strings here is about, on a 500 kV line, about 28 feet in length. So pretty long, and obviously takes a lot of insulation to stop that amount of voltage coming into a pole. Various types of wire, okay? Back in the day, everything was copper, okay? And then as we progressed, we got into aluminum, ACSR, and then you'll see all different variations of coated wire, okay? Remember, all this black that you're seeing on here, it is not insulation, okay? This is not insulated wire. It's simply a coated wire to protect it. Transformers, or in this case, a grid number, if you need assistance from us for whatever reason it may be, okay? Every one of our poles or transformers has a 10-digit number on it, okay? That 10-digit number near your construction site, you happen to dig into something, it doesn't need to be, right next to the dig-in location. It could be one pole or one transformer away. Don't put yourself in jeopardy. But that 10-digit number is the best information you can supply to us. Addresses are good, but that grid number is 10 times better. And more so, it allows if you can give us that grid number close to your site, we can actually put that into our computer in our truck, and it's going to show us the grid itself, okay? And we may be able to go to an operating device and actually de-energize the line before we even get to you, okay? Because we're able to pull up the grid, go to a sectionalizing device and say, you know what, I'm going to go out here. They dug into a three-phase underground line. We're going to get this section of line de-energized and remotely change some things around. So grid number, if it's possible, when you're calling in is very helpful. The underground, okay, 811, no matter what you are doing, okay, even if you're hand digging, the law states if you're hand digging, you don't need one. We highly encourage you to make the 811 call, okay? If you're an excavator, you know it, it's a law. It's being enforced by the PUC today, and they are strictly enforcing the law. So if you're seeing conduit coming down a pole, as in this case here, and you have excavation planned and you are not seeing red paint, you're seeing a gas valve or a water valve and you're not seeing yellow or blue, when you get to your site, please, okay, don't just think, oh, well, you know what, it mustn't run through my site. If you're seeing conduit coming down a pole and you're not seeing paint on the ground, you should re-notify that ticket, re-notify the first day you get there, okay? Call back in, re-notify, hey, I put my ticket in, there's conduit for, looks to be PPL or Verizon or Service Electric, whatever it may be, coming down this pole, and there's no paint on my job site. Re-notify your ticket, and we have to respond to you within 2 hours. It's similar to an emergency, but it's called a re-notify, and it gets us out there to get those facilities marked for you. If you see the obvious sign, please, make a call. Don't assume that it just doesn't run through your work zone. Transformer, this is the back side of the underground transformer, the big green box, okay? Inside of this area right here, the front side is all the primary connections, and this is where the transformation happens. In the back, this is full of mineral oil today, and the reason we like to show this is you'll notice right here, this is the hot side. This is 7200 coming in, does its transformation, and this is the secondary bushings on this side. But you'll notice this connection from here to the sidewall in the back of the box is about 3 to 4 inches, okay? If for some reason you hit this transformer box and knock it off its base, do not try to push that transformer back onto its base, okay? You don't know what happened inside of here, okay? Could something come dislodged, or did you dent this in and now it's only an inch away from this hot connection here, all right? If you hit it with a backhoe, run into it with a truck, knock it off its base in any way, call your electric company. It doesn't have to be us, it could be First Energy, whoever it is that you are, service area you're in, Pico, Dominion, Duquesne, doesn't matter, okay? Call your electric company, let them come out and get that back onto its base properly and safely. This can happen. In my 30 years with PPL, I've only seen this twice, okay? This wasn't even in our service territory, but we were able to grab a picture just to show you what can happen with these underground transformers, okay? Again, doesn't happen often, but they can physically explode. This is why if you have kids, you don't want them playing on or near these things. They're grounded, safe to walk up and touch, but I saw some disturbing videos recently on TV that I actually wrote in about and asked them to physically remove it from TV because there were 2 children standing on top of one of those transformers dancing around. Just not a good situation. The meters today for us, we don't physically have to come out and read the meter for what I call billing purposes. We do it remotely over the lines, and we can physically read the meter and send you a bill. We can also disconnect, okay? Simple mouse click, okay? Click of the mouse button today. With a meter, we can actually de-energize the meter, okay? Now remember, just like what I would say for non-payment, okay? Don't happen to pay your electric bill, something happens. We used to have to come out and remove the meter and disconnect your power. But today we can simply do it by clicking a mouse button, okay? Now, one thing to remember with that is that it's disconnected from the meter in to the home. Everything from the meter out to the pole is still energized, okay? By no means, unless you're a qualified electrical worker and do fast track for us, should you be removing a meter. Never remove a meter from the side of a home, okay? Electric shock, those signs are there for a reason. Obviously, it's very dangerous stuff. And your operation with heavy equipment, cranes, booms, okay? And again, remember, this says 10 feet if you know the operating voltage of the line that you are working near. Then OSHA tells you 10 feet. If not, and if you don't know the voltage, you've got to maintain 20 feet to these overhead facilities. I believe I have a slide coming up here to show you that OSHA standard. But here's a case. This actually did not turn out well for these folks because they put that boom up into the outer phase of that 12,000 volt line, and injury occurred. So again, understand the importance of your boom, where your boom's going to be. I say have a spotter, okay, that person that's off the side when you got to do a reach near our facilities, making sure that you can maintain a minimum 10 feet, if not more. And then there's the OSHA standard for the 20 feet if you're not sure of the energized facility voltage, okay? But 10 feet, if you get near some of our transmission voltages, obviously the distance increases. You get up near 500,000 volts, you're actually up around 35 to 38 feet that you need to maintain from our 500 kV transmission lines. Again, we just kind of show you these because unfortunately they happen. This gentleman got a high reach forklift, put material up on an industrial building, backed away, didn't put the boom down, and contacted the bottom phase of 69,000 volts of electricity. And what you're seeing at the base is basically what's left of that forklift. So again, we have a saying, if you got to work near overhead facilities, and that is look up and live. Look up and live, okay? Understand what's above you if you got to do some high reach work. Power lines, consider the equipment, consider it energized no matter what. Make the call to us. If you can move the equipment away safely, try to move it away and stay in that piece of equipment. You should not exit the piece of equipment if you contact power lines, okay? Safest place for you to be is in that piece of equipment, okay? Don't try to jump out. If you do have to jump out, I'll talk about that here briefly in a little bit on how you can jump out and get away safely. Small amount of electricity it actually takes, basically, plain and simple, to kill us, okay? And it's a pretty small amount. Remember, when you're working near our facilities, you've got 120, 240 in that service wire coming in, maybe 480. When you got a single wire up on top on those poles, 7,200 volts of electricity, and three-phase 12,500. Science tells us this. We pull this right from I've read on the old web. Okay, anywhere from 50 to 100 milliamps, 1/1000th of an amp is enough electricity to stop our hearts, injure us, or possibly kill us. 50 milliamps, okay? Again, you're working near high voltages, whether it's in the ground or above the ground, okay? To put this into perspective for you, if you happen to have a night light bulb in your bathroom, in your child's bedroom, okay, that night light bulb is a 7.5 watt light bulb, 7.5, okay? That night light bulb draws 62.5 milliamps of electricity to operate. A night light bulb, okay? 50 is enough to end your day. So be mindful, if you change, I know we've all probably done it, myself included, until I knew better, changing outlets in your house, not going down and turning the breaker off. I can do this, okay? And if you got shocked doing that, what's a receptacle in your home? Based on down in the panel box, it's probably connected to a 15 or 20 amp breaker down in the panel box. And if you got shocked, you had 15 to 20 amps of fault current that went through your body to go back and trip the breaker down in the panel box. 15 amps. It only takes 50 milliamps to stop your heart. Okay. You're going to do some work in the home. Take the short walk to the basement, go down and turn off that breaker. I turn the main off because I don't trust the label in the box. The label tells me it's feed in the kitchen. Is it? Okay, unless you did it yourself, then you may know, but otherwise you're trusting somebody else. So I turn the main off if I'm going to do something just to keep me safe. It's not going to take you long to do what you have to do. Okay, step and touch potential. So this is if you happen to be in an excavator or if you happen to have a teenager that's about to drive or just started to drive, be sure they understand this because they're not teaching it in school today. If you hit a utility pole with a vehicle or you dig into underground facilities, safest place to be is in the car, okay? Now, as some of those pictures shown, if the electricity stays energized, it's pumping the electricity, you're safe, okay? Even if it doesn't trip because you're of the same potential in the car, all right? But if it stays energized, doesn't send the fault current back to blow the fuse, what's it doing? It's heating things up inside. You got oil, gas, wiring inside of the vehicle or the excavator. Ultimately, could it catch fire? It may. And if it catches fire, you can get out of it safely, okay? But you can't just open the door and step out. What you need to remember is that electricity flowing into the ground creates what we call ground gradients, or the best way I can explain it, if you throw a rock in the pond, okay, what happens when the rock hits the pond? You get the ripple effect out across the water, okay? Electricity does the same thing as it's entering the ground, okay? And it creates those ripples in the ground. Can't see them, can't smell them, can't taste them. Trust me, they're there. Each ring is a different ground gradient. If you get your feet between two different ground gradients, you become the human jumper cable, okay? So if you have to, open the door, get up on the door sill, jump out and land about 2 feet shoulder width apart, okay? Once you're out, you still cannot take that first step. You got to shuffle away. The easiest thing that I think you can do, shuffling away, heel to toe, never lift your feet off the ground, shuffling, heel to toe, and shuffle away. The all important question, how far are you going to shuffle? Minimum of 1 pole, okay? If you hit this pole, okay, you got to be shuffling to the next pole or more, okay? Shuffling away 100 feet or more, heel to toe, never lift your feet off the ground. So that's how you can get out of a car if you happen to hit a utility pole and wires come down. Hopefully it never happens. Or if you happen to dig into underground facilities, catch it with your overhead boom and you can't break free, stay in it. But if you have to get out, that's how you can get out if you need to. So again, hopefully just took a little something from this. We are available to do a presentation similar to this. Generally, it's about an hour-long presentation. We kind of just gave you a brief overview here this morning and talk to you so that you understand the dangers of electricity, the small amount of electricity it actually takes to injure us or worse, and just understand what you're working near. So we're available for your company. If you'd like us to do a presentation, please reach out to myself. John has my information, my counterpart, Steve Kraus. And we do offer, this year we had to cancel them all, but this is what we call our live line electrical safety exhibit. We actually take this around to our first responders, our fire companies, large contracting groups. We ask for a minimum of 50 people, and we energize this exhibit at 7,200 volts single phase, and we physically show you what happens, okay? Ladder contact, animals, trees, and human contact. Even the underground, we got a big green box down here, and we can walk through and show you what happens if you dig into energized 7,200 volts. So this would have been our 5th year with this, but COVID kind of canceled everything for this year, and we had to resort to the Zoom presentations. But if you're interested in something like this, again, reach out. My calendar for next year is filling up pretty quick, but we'd be willing to come out and do some education with this as well. So again, can't say enough to KCA for giving us some time here this morning. And any questions out there, John?
I didn't receive any texting or emailed in or whatever. But yeah, if there's any questions, we have a few minutes now. I don't see anyone unmuting. So I think you thoroughly explained everything, as always.
Awesome.
Doug does a great job, everyone. And again, if your company does want to bring him and PPL to your office or your job site or whatever for training, please get in touch with him or contact me, and I'll connect the two of you.
Absolutely.
But yeah, on behalf of the KCA, thank you to Doug and PPL for today's training.
All right. Thank you. Take care.
All right. See y'all.
Thanks, guys.
Okay. Perfect.
All right. Hey, John, if you feel like maybe you want to set something for winter, shoot me an email,
Yeah.
December, January, maybe things slow down for folks or they're looking for things at the start of the year, to kick off their training for the year.
Yeah. I was thinking too, this year obviously it didn't happen, but during stand down week, which stand down week is always the 2nd week of May, for a while there, what we were doing was picking one day during that week and having a half day of safety training.
Okay.
And we went to the Radisson in Camp Hill, and
Okay.
they had a nice big parking lot. So you could probably set up outside and
Absolutely.
yeah. And we
Yep.
just bring in 3 or 4 different presentations, maybe on fall training. We could have
Yep.
this safety training and just kind of continue to beat the drum on training. And
Sure.
so, but yeah.
Just have to get me a date as soon as you can.
Yeah.
And, like I said, most of what I had for this year with the trailer, we had to move to next year.
Okay.
But then some haven't gotten back. So, I have some flexibility yet, but if you know what date that is, shoot it to me and we'll get you on the calendar.
Okay. Yeah.
That'd be awesome.
Hopefully May of 2021, we'll be leaving the house. So
Yeah, I hope so.
Me too. Enough of this.
Yeah.
Awesome. All right. Well, thanks, Doug.
All right. Thank you. Take care and be safe. Anything ever comes up, don't hesitate. Reach out to me.
Awesome. Sounds good. Thanks.
Okay. Take care.
Yeah.